This is Algebra 2, Unit 2, Lesson 7 on key figures of functions. What we're going to look at in this lesson is some of the terminology that we learned back in Algebra 1. And so that everybody is on the same page when it comes to what different definitions are. Okay, so we have the function y equals f of x that is graphed over here. And let's look at the different parts of the graph that we can identify. All right, the y-intercept of the function. The y-intercept of the function is where x is 0, and then you have the y, and where it crosses the y-axis. So that would be, the y-intercept would be y equals 2. It would be this value right here. Y is 2. All right, state the x-intercepts of the function. Well, if the y-intercept is where it crosses the y-axis, the x-intercept is where it crosses the x-axis. So what would be the x-intercepts? It would be x is equal to 1, 2, 3, 4, 5, 6. X equals -6. And the other one should be at 1, 2, 3, 4. X equals 4, which is right there. Those are the x-intercepts. Now, since these are the x-intercepts, what is another name that we have for x-intercepts when they're referred to? Well, when you have an x-intercept, what would be the coordinate that is 0? It would be y is 0, so you have x0. So these are also called the zeros of the function. So the x-intercept are called the zeros because y is equal to 0. Over the interval from x is greater than -1 but less than 2 is f of x increasing or decreasing. All right, so let's look at our interval. -1 for x would be right here. And to 2 would be right there. So we are looking at what the function does as it goes from -1 to 2. So this is x equals -1, and this is x is equal to 2. Is the function increasing or decreasing? Well, the function is actually increasing. It is increasing because as x increases, as x moves to the right, which means it's increasing, the y value, or f of x, also increases. So as x increases this way, the y is also increasing. As we move across the function from here, you can see the y values are increasing until you get to 2. Now, let's give the interval over which f of x is greater than 0. What is a quick way of seeing this visually? All right, now first of all, let's make sure we understand what's being asked here. F of x is greater than 0 means that when you do the function and you put your inputs in and get your outputs are greater than 0. Remember, your outputs are y's. So where your y's are greater than 0. So what would be a quick way of seeing this visually? All right, let's think about this for a second. We said that y is equal to 0 when you're on the x-axis because that comes from the x-intercept. Okay, so we know that the x-axis we know is y is equal to 0. So if we were seeing this visually, how would we know where the function is greater than 0? We would look where the function is above the x-axis. All right, so we would be seeing where the function is above the x-axis because that's where y is equal to 0. If it's above it, it would be greater than 0. So any value that falls above the x-axis. So it would start here and it would end here. Okay, now since this is an interval, you are looking for x values. Okay, so where does this start to be greater than 0? Well, it starts to be greater than 0 at x equals 1, 2, 3, 4, 5, 6, -6. However, it stays increasing and decreasing and increasing and decreasing and doesn't get back to 0 until you get to x equals 1, 2, 3, 4. So the x will fall between -6 and 4. All right, now, is f of x greater than 0 actually at negative 6? No, f of x equals 0 at negative 6, so that is not going to be included. So x would have to be greater than negative 6, but without the line underneath it. And it stays that way until you get to 4. When you get to x equals 4, again, it's equal to 0, not greater than 0. So x has to fall between negative 6 and 4. Now, you can also write this with interval notation. Interval notation, that's when you use the parentheses and the bracket. Interval notation would be using not including negative 6, but not including 4, but everything between it. It would be parenthesis negative 6, comma 4. So that's interval notation. You start at negative 6, don't include it, and then go to 4, don't include it. All right, state all the x coordinates of the relative maximums and relative minimums. What are relative maximum minimums? Those are turning points. Whoops, turning points. Sorry about that. Turning points. That is where you change from increasing to decreasing or decreasing to increasing. So let's take a look and see if we can figure out where the relative maximums are. All right, so a relative maximum would be where a function increases and then changes to decreases. So the rel maxes would be, let's see, this is increasing and then it decreases right here. So one relative maximum would be right there. So that is the relative maximum would be at x equals negative 4. There's the first one. Okay, and then we also have relative minimums. What's happening from negative 4 until you get to negative 1? Well, at this point right here, it is decreasing and then it starts to increase. So that would be a relative minimum, would be at x equals negative 1. Okay, then what happens at negative 1? Well, it starts to increase again until we get to x equals 2. So we're increasing and then it's going to change to decreasing. So that makes it a relative maximum. So x is equal to 2 would be a relative maximum. And then it decreases and keeps decreasing until we get to x equals 1, 2, 3, 4, 5, 5. All right, and then it starts to increase again. So it would be at x equals 5. So the turning points when you're going from increasing to decreasing or decreasing to increasing would be the relative maximums and the relative minimums. Okay, so if we can see where our turning points are, this makes a bump at the top, making a maximum, bump at the bottom makes a minimum. Bump at the top, bump at the bottom. And you can see where they are. So this would be your max, min, max, min. All right, now we just said that relative maximum minimums are the turning points of the function. So the difference between that and an absolute maximum minimum, the absolute would be the highest or lowest maximum or minimum of the function, turning point of the function. Okay, the maximum would be the highest, the minimum would be the lowest. So let's see if we can figure out the values of the function and where they occur. Remember, the values of the function is the y, and where do they occur would be the x. So let's take a look at the absolute maximum. All right, so here is our function again. What would be the highest turning point of this function? Well, let's see. The highest turning point would be right here. So our absolute maximum would be at 1, 2, 3, 4, 5, 6, 7, 8. It would be at y equals 8. This is the max. When x is equal to 2, because this is the point 2, 8. All right, so that would be the absolute maximum of the function. The absolute minimum of the function would be the lowest y value on the function at the turning point. So where is the lowest value of the function? Well, it would be at x equals, let me see, turning point would be, lowest turning point would be right here. This could be the minimum of the function. If we assume that this one right here, if this function goes on, but we can't see farther out, this might turn up like this, we don't know. So from the one we know definitely is a turning point, it would have to be right here. Okay, so that would be the minimum of the function. This is at y equals -2 when x equals 1, 2, 3, 4, 5. So it would be y equals -2 when x equals 5. So probably this might actually be the turning point, but we can't see the rest of the function. So from what we have right here, we know this is definitely a turning point because it changes from decreasing to increasing. All right, now let's state the domain and range of f of x using interval notation. Okay, so the domain, remember, is the x values, the range is the y values. So let's take a look at our graph. For the domain, what is your lowest x value? All right, now remember, domain would go to the left and right. So I'm going to draw, highlight the lowest x value would be right here. That hits the graph, the lowest point would be right here. The highest domain, follow the x-axis along, would be right here. Okay, so the lowest x value, 1, 2, 3, 4, 5, 6, 7, 8, and the highest would be at 1, 2, 3, 4, 5, 6. All right, so x is between 8 and 6. Now, does it include 8 for the domain? Yes, it does. So since it includes -8, we would use a bracket because that means include. Then it goes up till we get to x equals 6. And then that's also included, so that would be a bracket. The equivalent of this, saying this in the other notation would be like this. These two are equivalent. These mean the same thing. So this is interval notation using the brackets because they are included. Okay, let's look at the range. The range would be the y values. The y's are looked at up and down. So we want to go to the lowest y value, which would be right there, and the highest y value, which would be right there. So we follow the y-axis up and down. All right, the lowest y value. The lowest y value would be right here, which is at -4. And the highest y value is up here, is y equals 8. So those are both included values. So it would be bracket -4, comma, 8. Close your bracket. So if this is equivalent, if you use the other notation, it would be -4, y, and 8. Now notice the brackets mean equal to. They're including those values. All right. If a second function g of x is defined by the formula g of x equals 1/2 f of x plus 2, then what is the y-intercept of g? All right, well, we've got to think about this for a second. The y-intercept, what do we know about any point that is the y-intercept? Well, we know it will always be the point 0, y. That would be the y-intercept. X is always going to be 0. So, if g of x is defined by the formula g of x equals 1/2 f of x plus 2, that means what is the y-intercept of g? We're saying when x is 0 on that function, it would be 1/2 of f of, plug in the 0, plus 2, which would be 1/2 of f of 2. All right, so what we need to know is what is f of 2 on this function? F of 2 is when x is 2 on this function. What's your y? Well, let's see. X is 2, y is 8. So this is going to be 1/2 of 8, which is equal to 4, because f of 2 is equal to 8. So there we go. All right, now let's look at exercise 2 for a second. We're going to do this one together in class tomorrow, so as a little review. So see if you can plot these points and answer some of the questions that go through A through F. Let's take a look at the last exercise. Okay, now for exercise 2, we are going to graph a function in class tomorrow and then see if we can figure out what the values are. If you want to try this out yourself, you can. See what you can do. And the same thing for exercise 3. So that's the end of the video for today.